So let me disconnect this wind source for a moment. Holding the Y key, we can create this thing and just cut it from my simulation and add another one thing. So it's my smoke source, it's my simulation, it's my wind. And let's create another one. I call it, we can call it like a curve velocity. Go inside. Again, I want to go to the other object because I want to see the beginning of my simulation. So now I want to create a curve. Let's draw a curve from this and maybe try to stop building, and let's me see, what do we have? Yeah, nice, I guess it's nice. You can go to NURBS and to create a little bit more different curve. So let's get a point, and I want to drag it over here to create like a interesting curve here to see the how it's changing direction. All right, so here's my curve, and I can now hide all other. I don't want to see it. Now we can see that we have some points. So we have just 1, 2, 3 points, and it's the NURBS type. So I want to add a resample node because I want to add the points in my curve. All right, so along all curve, I have a bunch of points. To apply a different length, to apply a different point number, we can define the length parameter. I can increase it a bit, like 0.25 maybe even more, because there is a lot of points, and the amount of points depending on your angle. So if you have a huge angle, maybe you need to increase the point number, so maybe 0.4, something like that. Maybe apply with this later if you want to. So now I want to create velocities, or I want to create the path, in fact. And basically what I want to do is take normals from my points, and align those normals on the direction of each point. So each point can take a direction to another one, and this will create normals along this curve, and then we can take those normals and convert them into velocity field. So before we do that, we need to get a normals. So I go to face node, connect it here, and inside of this node I want to enable pre-compute normals. So basically should have them, they're pretty small here, and you can see that the direction is on X somewhere here, so it's like a perpendicular to the curve, but I want to align those normals, and that's why I want to use the polyframe node and the tangent name. So if you go to polyframe, and we have a tangent name which is tangent U, but I want to disable that and type N, which is normal. So our normals have an N, the capital N. This is our attribute normals. So now we can see that our normals, where's my points, and it's slightly, you can see that each point has a normal along the curve. You can see it, right? Yeah, here we go, we can see it. Nice. It's a little hard to see, but we can see that. So you can disable for a moment. And now go and add the attribute warp, when we can use those normals to get a velocity. So can call it get velocity. I just want to disable enable the display flag. Let's go here, and what I want to do, I can connect my normals to velocity, but in my case, if we see here that our normals is going backwards, but if I select now points and velocities, we can definitely see a nut. It's very hard to see, really. It's really hard to see our velocities. So we have a normals. We can see the normals, okay? And I want to push velocity backward. So to do this, I add a negate node here. Okay, so I make those velocity normals backward. Okay, velocity, we have this. So now we can see we have normals and velocities. Cool. So now how we can use or apply those velocities for our simulation. Well, for the start, as in always, we can go to the Pyro source and add a velocity attribute. Well, in fact, we can avoid this stuff, because if we use the same point amount and add the velocity attribute, well, I think that we don't need to do this. Anyway, we'll have the same attribute, but we will have the particle scale. So that's why I want to add this, because we can control the particle scale. So now add a velocity, and default is y11. So if you go to velocity, you can see that there is no, in fact, changing for the velocities, because we use this direction if you don't have a default value. So what do you mean default value? It's a value when if we don't have a velocity, we put this value. But if we have velocity, we still have the same velocities here. So now we have a particle scale and particle group here. So using the particle scale, we can go and rasterize volume attributes. So basically we have a particle scale here, so we can even avoid this stuff and try to work with velocity without the Pyro source. Okay, so that's how we can do. Or with this, it doesn't have too many difference, because we can add the particle scale and here and here. So that's your choice, you can do whatever you want. So what do we have here? That's an interesting, have some elements over there. So here's my curve. If we go back here to this curve, and I rasterize my velocity, can normalize it if you want to, and can play with the particle scale to get a bigger volume for my velocities. Now, how we can see those velocities. So we definitely have the volume here. So we definitely have volume V, and we have some size, we have some voxels over there. And how we can see those velocities, in fact. Well, definitely we can use the the node, call it volume trail. So let's call volume trail. Connect my volume with velocity field here, and connect my any geometry I want, let's say grid, or we can add a box off for the first input. We can use the points to trail. Okay, so we can use, because I have not very linear stuff. Well, okay, let's try the grid. Maybe I try to rotate this grid as I want to. So XZ, no, oh sorry, YZ play. Let's go to top view for better looking how we can control this stuff. So I can rotate it by y-axis and like maybe 45 degree. It's almost done. Okay, something like that. Now I can go to perspective view and try to place this plane to cut my velocities somewhere like this. So maybe a little bit bigger, 15 by 15, come on. Okay, 15 by 15. And now connect it to the volume trail. You can see some points here, the bluish, the red one. If I increase the number of rows in column, and basically you can see that it used the points of my grid. So the more points inside of this grid, the more interesting will be my field here. So now we can see how it's applied. So we have some areas, not just a spline. Using our scale, particle scale, we define the area of an influence of our velocity field. Okay, so now it has volume, so not like a path, this thin line. We have a huge volume here. All right, but it's just a visualization to to have an idea where is our vectors, in fact. So go to null object and get out, let's call it path. So we just understand that this is our one pass. Let me just, yeah, V, that's all fine. And connect this. So, by the way, I forget to connect my voxel size from this to my source. So copy parameter and paste it here to my volume rasterize, paste relative reference. The same for wind. So it doesn't matter anymore, but you should know this. Okay, so we can copy the wind source because many of those parameters we will keep, and that's gonna be our path source. The same velocities, just let them scale 1 by the moment, and we're gonna see a result of that. And I want to have a path to understand the direction for my movement, you know, to see is it works or not. Maybe it doesn't work. Maybe the smoke will move somewhere and not use my velocity. So I definitely should have, oh, sorry, I forget to change the path. I changed my velocity, but I forget to change the path. All right, so that should be a curve velocity, the out path. And now this smoke is going pretty fast. I think that is too fast, because you need to understand that our vectors with the very high rate sometimes will push our smoke outward because of the huge velocity. So we need to, you know, have velocities which can reduce this force and try to keep the smoke with the existing path. So let's make a bigger scale. Go to curve velocity, maybe add a little bit more points. So maybe 0.25 for the length. So it will add a bigger amount of points, and get a particle scale, maybe 10. Okay. So it should be like 1 meter, somewhere like this. If you go to scale, so you can see it's here. So 10 is here, so it's not using the direct scale, so it's not at 10 meters. Okay, so just make a pause to see the final path. And I reduce a little bit of my initial velocity from the source because, you know, it doesn't work very good. And now you can see it still have, you know, some troubles over here because it doesn't match on this curve. It's a very big angle. So anyway, you can play with the setup here with the settings, but you definitely can see that it works. And what we can do else? What we can do else is go in here and maybe play a little bit with velocity amount. So we have a velocity from here and we send it into the pyro source. So let's go and add the attribute triangle. Attribute triangle, and what I want to do, I want to increase my velocity depending of the position of my point. So the bigger y position here, the bigger velocity. So how we can do this? Well, in fact, we have the y, and the maximum is 11. All right. So maximum is 11 for the y. So let's take an I don't know, like float attribute height, and it's gonna be my p dot y. So we oh, sorry, forget to add a attribute. Sure. So now we have the same, exactly the same number over here, and now I want to take the same stuff and maybe apply a fit node. So I want to take our 0.1, and I don't know what I want to get. Oh, actually, you know what? Let's just add here and fit this py. And the minimum should be 0, the maximum should be 11 till 0, 1. Okay, so, and why I don't want to do that. Fit 0, 1 with the points. Okay, because we want to fit basic fit. Okay, so now we have without 0, 1, yeah. We have an interesting thing when we have a difference between 0 and 1. Okay, 0 and 1. And then what I want to do, I can take my velocity, come on, and multiply it by the height. So what it should look like. If you go to our points, enable velocity, definitely can use an add right now just to delete points, delete geometry, delete more points. So it's go here. So for now we have all our velocities the same. Now when I connect to attribute wrangle, we should have velocity multiplied by height. So if you go to my velocities and the maximum velocity was 0.78 and doesn't work somehow. Get a fit. So from this, no, it's working. It's all working because you can see that we multiply the smallest velocity is here and we multiply it by 0. So it became a 0 multiplied by 99009 and it became too small. So let's see what do we have there. So you can see that a small velocity here and bigger velocity is there. Twice bigger. Yeah, it works. Okay, maybe not twice. Maybe like this or this. So it's much bigger over here. Well, let's take a 5. I don't know, just for a test. I don't know how it works. Let's see what we have. So the scale for my velocity should be like this. The higher my point, the bigger velocity we have there. We can do the same with the particle scale actually, okay? So the smaller particle scale here and the bigger one there. So just make render here. Okay, so let's play again. It's interesting what result do we have. And here you go. So it's pretty instant result. You can see that it's not adding too much velocity over here because it's going like to 0 and then it's speed up. So again, there's a lot of speed here, so maybe I can reduce the difference between this and this. So now maybe 5, maybe 4. But anyway, it's always good when you can, try to create some velocity, just custom velocity. And there's not too many projects when you need just, follow straight to the curve. In many velocities, you just want to add some direction, and sometimes it's good when you have a non-linear direction like this, so we can, manipulate using different curves. We can use small curves just to add some small motion in some areas. So you can play with that. You can clone those curves using the copy or something like that and add a lot of different kind of motions on the distance. Okay, so we can play with that. So it's not so hard. You can see that it's pretty simple to create and manipulate our fire simulation using some custom fields. Nothing very, very fancy. And I can just remove this for a moment. I don't want to see it. Okay, so let's find out how to work with another funny thing.